See, in group 16, sulfur has many allotropes due to its high catenation tendency. That means sulfur single bond strength is high.
Yes.
And out of many allotropes, the ones which are more important are one alpha sulfur, which is also known as orthorhombic. It is the most thermodynamically stable allotrope, usually observed
Mm-hmm.
in volcano erupts, and it will have a yellow crystalline form.
Right.
It is insoluble in water, but it is soluble in CS2.
Hmm.
And it is prepared by, dissolving the roll sulfur into CS2 and slowly evaporation of CS2. Sorry, roll sulfur is the other form. In fact, you imagine like this, whatever the sulfur that is erupted, that is been, most likely rolled kind of. That's why it is called as roll sulfur.
Oh,
So
okay.
that sulfur, when you add it to CS2 and slowly evaporate the CS2, the
Hmm.
crystalline form which is left over is the alpha sulfur. This alpha
Right.
sulfur converts into beta sulfur at a particular temperature, and that is called transition temperature, 367 or
Right.
9 kelvins. Okay,
Hmm.
and this is beta sulfur. And beta sulfur is also known as the monoclinic sulfur. And melting point of alpha sulfur we'll take the melting of alpha sulfur in a dish and cool it down till it crest is formed like this. As we start cooling, the first crest will start forming on the surface.
Crest.
Crest is a solid chipping which is happening on the surface. Okay,
Okay.
and you make two small holes, right? So then you let whatever the liquid which is there to evaporate. Okay,
Okay.
after a while, a needle shaped white color sulfur is formed in between, and that is called as the beta sulfur.
Okay.
Correct?
Okay.
It's nothing but uh, a crystalline difference in terms of its arrangement. If you have an orthorhombic arrangement, it is going to be alpha sulfur. If you have a
Alpha. Hmm.
monoclinic arrangement, it is a beta sulfur.
Yes.
Next, we have a gamma sulfur. It is formed when hot concentrated solution is chilled in ethanol or CS2 or toluene. Okay.
Okay.
So alpha, beta, gamma sulfur consist of acid rings in a crown, conformation like this.
अच्छा all are in crown form only.
Yeah. Hmm. Next, then we have an epsilon sulfur or the angle sulfur. It is
Hmm.
usually rhombohedral in form. It is prepared when you have Na2S2O3 in hot and concentrated HCl and extracting sulfur in a toluene. Okay, so
Okay.
this
Yes.
Na2S2O3, when you add it to concentrated sulfur, it will convert into sulfur plus H2SO3. So this sulfur, which is precipitated form, if you add it to toluene, it will start
Mm-hmm.
crystallizing, and that crystalline form is what we call it as angle sulfur. This usually have
Okay.
six sulfur, uh, six membered ring, which is a chair
Chair.
form. Okay,
Hmm.
clear beta.
Yes.
Now learn this like a story beta. Okay, what exactly happening? Notice this. Sulfur in its orthorhombic form, when you heat around 119 degrees, it will start melting.
Right.
So this becomes what?
Right.
Melting point.
Right.
And then the molten form, if you take it to around 160 degrees, the acid chains will break and convert most of them into radicals, SS radicals. Okay.
Okay.
Next, at 200 degrees Celsius, the long chain of sulfur will form because there are long radicals here. All the
Hmm.
radicals will, connect with each other. Got it? Just a
Okay.
minute. Somebody's at the door. So it starts becoming a long chain now. Once it becomes a long chain, it will become viscous.
Yeah.
And this viscous thick solution, if you bring it to larger temperature, which is greater than 200 degrees, again it will start converting into smaller chains and some rings. Got it?
Oh, rings.
So
Okay.
it will start decreasing up to 200 degrees. What do we happen? The viscosity starts increasing. And as you start
Hmm.
crossing 200 degrees, the viscosity starts decreasing again.
Decreasing. Hmm.
And as you reach towards the temperature 444, that becomes the boiling point of sulfur, where everything will convert into vapor.
444.
Hmm. That is the boiling point of sulfur.
Okay.
And this will start vaporizing. As it comes into vapor, most of the vapors will have S6 and S8 cyclic structures. Correct? These
Yes,
vapors
sir.
usually have S6 and S8 forms.
Hmm.
And if you start increasing the temperature of the gases, which is vapors, further up to 600 degrees, it will start converting into and molecule S2. S2 is very similar to that of uh, oxygen,
O2.
right? Yeah, O2, wherein just like we had pi star 2px1 and pi star 2py1, where the two unpaired electrons in O2, the same logic fits for sulfur. It will have pi star 3px1 and pi star 3py1. Okay,
ठीक है.
and this would
Yes,
be
sir.
blue color and paramagnetic.
Okay.
Correct. So this is the complete
Yes,
journey
sir.
of how the heat affects the sulfur. Clear?
I need to remember each temperature पे क्या होगा basically.
Only two. Can you see that? Marked
Yeah.
ones.
uh,
Only these two. Hmm?
ठीक है.
Next, compounds of sulfur. See, hydrogen sulfide. How it is prepared? It is prepared by acidification of FeS with HCl. Okay. See, FeS when you add it with HCl, it will start vaporizing. H2S vapors will come. Okay. The same can be done with SbS2, Sb2S3. That will become SbCl3 and H2S. The apparatus that is used to make this is called Kipps apparatus. This is there in the lab manual. When we discuss all the lab manuals, then I'll come across this. Okay. Next, properties. It is colorless, rotten egg smelling. It is a good reducing agent. In fact, it literally reduces almost everything which is possibly added to it. K2Cr2O7, KMNO4, X2, FeCl3, ozone, peroxide, even SO2. Okay. As it reduces in all the forms, what does it give it? A colloidal sulfur. That is important. Okay. So it gives a colloidal form of sulfur. Colloidal sulfur is like a dirty white color. Uh, you know, white colors mostly like a turbid. Okay, not like a
Suspended
complete
in
solid.
solution.
Yeah, more like suspended in solution. Okay,
Hmm.
and then if you react H2S with cadmium, it will give a yellow PPT. With lead, it will give a black PPT.
Yeah, PPT.
And you know that silver, mercury, bismuth, copper, even they will give you black precipitates. Hmm.
Yes, sir.
The second compound is SO2. SO2 is again somewhere in between, so it can act like oxidizing agent as well as reducing agent. How do we prepare is simply burn the sulfur in O2. Combustion will happen. SO2 will be major, a minor product which is SO3 will be formed. Or you can take sulfides or thiosulfides as thiosulfate and add it to dilute HCl. It will convert into SO2 and sulfur. Here Na2SO3 also converts into SO2 and H2O. Got it?
Hmm.
If you have FeS2, FeS2 has a peroxy linkage like this. Okay, thioperoxy
Okay.
linkage. So you have S and S with minus and minus, and this has been covered with Fe plus 2. That's how it has become FeS2.
Right.
That on oxidation, iron will get oxidized and sulfur will get, sulfur will get oxidized too. That is converting into SO2. Clear? And
Hmm.
oxygen is getting reduced in short. In the case of SO2, structure wise, if you notice, it would have, this is the configuration 3s2 and 3p4. Because it has 3p4 and I require only two oxygens to make two sigma bonds. So which means one electron here and one electron here, I can keep it. Okay. And then
Uh-huh.
I keep two unpaired also just to make the pi bond formation. And the lone pair will be present along with that SO2. So therefore, we will have this
Right.
sp2 hybridization, and this is how it looks like. which has one p pi and one p pi d pi. Okay,
Right.
done. So you can see it is
Yes, sir.
colorless, pungent odor, suffocating effect is observed. Now, it acts like both oxidizing agent as well as the reducing agent. Reducing agent where SO2 is converting into SO4 2 minus. Oxidizing agent where SO2 is converting into colloidal sulfur.
Hmm.
Okay, next. Addition reactions. You can see SO2 plus Cl2 will make SO2 Cl2. Half O2 will make it SO3. PbO2 will make it PbSO4. Okay. So in
Okay.
all these reactions, you will notice, oxygen is getting added to the SO2 itself and convert into these products. Now, SO2
Hmm.
can act like a bleaching agent also due to its reducing behavior. What does that mean? See, I take SO2, react with O2 in the presence of H2O. So what would happen? You will get SO3
Right.
plus two nascent hydrogens. Okay. And see, SO3 with nascent hydrogens here, right, will convert back into SO2 and H2O. Got it? Now think
Yeah.
about it. What happens? Here, uh, usually this is a temporary bleach, beta. Okay,
Hmm.
this is temporary bleach. So if you have any SO2 on the surface of it, it will convert into SO3 first, correct? And SO3, when the H is brought back, then it will become SO2. How would I explain? Um, Suppose if you have a piece of paper which is, wet, correct? A wet paper.
Hmm.
So imagine something like that when you bring it to the heat on a candle over, suddenly the imprints are been observed. Okay. So basically, if the ink had SO2 in it, okay,
Okay.
so it get temporarily bleached, correct? So
Hmm.
in aqueous solution, it will get bleached. Bleach means it will become white. So paper looks white completely. Hmm?
Right.
And the minute you bring it to the candle now, what happens? So whatever the moisture that was observed, that will come out. Hmm?
Hmm.
So while moisture has to come out, the SO3 has to give away the nascent hydrogens as well. So it will
Right.
take away that nascent hydrogen, convert back into SO2. So now it will start appearing whatever the colors which were there earlier. Okay, that's how it will
Hmm.
act like a temporary bleach. Okay. Hmm. Next, check out SO3. SO3 is already at the highest oxidation state, so it can only act like a oxidizing agent. It cannot be reducing agent. So 2SO2 plus O2 in the presence of vanadium pentoxide will give you SO3.
Yeah.
This is a standard process which is also used to make H2SO4. So this is known as the contact process. Hmm. And next,
Hmm.
structure of SO3, you can see it is a trigonal planar structure. It is sp3 hybridized. It has three pi bonds, out of which one pi bond is p pi p pi, other two pi bonds are p pi d pi. Hmm.
Hmm.
When SO3, which is non-polar, if you try to, cool it down and solidify, the solid form of SO3 will exist as a cyclic structure like this. SO3 thrice. This is that structure. SOS
Yeah.
three bonds, and then we will have double bonds. So this kind of cyclic structure is called as gamma sulfur trioxide. Hmm.
Hmm.
While if SO3 starts forming a chain-like structure, straight chain, then that is called beta sulfur or beta sulfur trioxide. Okay. Now, if at all we have cross links on a linear polymer, so that means if the same linear polymer is there, and you will have all the cross link forms here like this. Got it? Sorry.
Yeah.
Yeah, sorry. Cross link forms of this beta form. Then that is called as alpha sulfur.
Alpha sulfur. Hmm.
SO3 is an oxidizing agent. It can oxidize HBr to Br2. Okay. So HBr is converting into Br2. Same happens with HI also. Phosphorus can get oxidized to P4O10 as well. Okay. So this is basic reactions that you might need to know. Next is SOCl2, known as thionyl chloride. Thionyl chloride, we have seen this as the reactions of PCl5. PCl5, when you react with SO2, you know that two chlorines will make a bargain for one oxygen. So we'll get this as POCl3 and SOCl2. SOCl2 on hydrolysis will give you H2SO3 and HCl. H2SO3 is acid, HCl is acid. That will, as you warm, SO2 gas will come out of it. Okay. SOCl2 will also react with NaOH. You can think this way: SOCl2 actually is converting into HCl and SO2. And SO2 can react with NaOH, convert into Na2SO3. Correct. So this is the reaction that will take place. And these are all the standard reactions which we know. SOCl2 can react with alcohol and acids to replace the OH groups with chlorides. Okay.
Right.
Next is sulfuryl chloride. That is thionyl chloride. SOCl2 is called thionyl. SO2Cl2 is called sulfuryl.
Sulfuryl. Sulfuryl, sorry.
SO2Cl2 will form SO2Cl2, okay, with Cl2. PCl with SO3 will also become POCl3 and SO2Cl2. Now, SO2Cl2 plus H2O will make it H2SO4 plus 2HCl. And you see, SO2Cl2 plus 4 moles of NaOH will give you Na2SO4 plus NaCl. Okay. And if you have a tertiary, in fact, not just tertiary, any alkane, and when you react with SO2Cl2, it will behave very similar to that of bromine's selectiveness. That means bromine being very selective, it will go to a most stable radical state. The same thing happened with this one also. If you have a tert butane, the most stable place is this one, and that's where the chlorine will attack. Okay. In organic, we call it as Reed's reaction. Next, SO2Cl2 plus P4 will convert into PCl5 and SO2. Okay. These are some reactions which you need to know. Now, what are the oxo acids for group 16? Okay. See, sulfurs mainly has these six of oxo acids, starting with sulfurous acid. Rus, in the case of sulfur or sulfur family or group 16, we usually take it this way, beta. Anything up to +4 is us acid. +5 and +6 is an ic acid. Okay, up to +4 is us acid, OUS. And within that, if you have +4 only, it is sulfurous acid. If it is +2, that is lower oxidation state, we use the word hyposulfurous acid, like that. Okay.
Yeah.
So you can see H2SO3 +4 oxidation state. So it is an us acid. It has 2 hydrogens that it can deliver. So the basicity is 2. Next, pyrosulfurous acid. Next, H2S2O5. Here also sulfur will get connected, correct? So problem here is, when you take 2 moles of this, remove water out of it, right? We always learned that there should be an oxygen connection, correct? But this is that exceptional case where oxygen connection molecule is weaker. That will tend to change itself into sulfur-sulfur bond. So this one is a stronger bond now. So therefore, pyrosulfurous acid is only one of those exceptional forms where oxygen linkage is not observed. It is not like sulfur, oxygen, sulfur kind of formation. It is only sulfur and sulfur connected. Clear?
Okay, yeah.
This is about H2SO5.
So, in this one, wait, which one is +5? Which one is +3?
Here, now notice this. This one is +3.
And that one is +5.
+5.
Okay.
Next, thiosulfurous acid. Thiosulfurous acid, as in, whenever you have an acidic form, you make sure that there is always a sulfur-sulfur collection. And on either side, there should be uniformity. If there is a uniformity, then we use the word thio. So you can see uh, thionous acid, thiosulfuric acid, all of that. So this is, thiosulfurous acid. Hmm. Next is sulfuric acid. Sulfuric acid is H2SO4. Got it?
Right.
And after that, it is thiosulfurous sulfuric acid. I told you this before. Just replace this oxygen with sulfur. The properties remains the same. That means this oxygen has -2 oxidation state. The replaced sulfur will also have -2 oxidation state. Okay.
Right.
Next is oleum. Oleum is nothing but pyrosulfuric acid. So basically, if I take 2 moles of sulfuric acid, remove water out of it, then you'll get SOS bond. The rest of the structure is same. So this is pyrosulfuric acid. Next is dithionic acid. Okay.
Right.
Dithionic acid as in sulfur and sulfur connection. Okay. So just now I told you, when you have sulfur and both sides the uniformity is there, then that is thionous acid, thionic acid. If you have two, then you call it as dithionic acid. Oxidation state is +5. Monoperoxysulfuric acid. Monoperoxysulfuric acid as in the same sulfuric acid with an OOH bond. Okay. So that will become monoperoxysulfuric acid. Next one is peroxide disulfuric acid. So you'll have, H2S2O8. So we'll have SO, O, and S. Please check this out quickly.
Okay. Yeah.
Next, check out. Last thing we need to learn about group 16 is about sulfuric acid. Okay. Sulfuric acid is prepared by mainly two methods, contact and lead chamber process. The idea is very simple. You take sulfur, react with O2, you'll get SO2. SO2 in the presence of O2 again with vanadium pentoxide will convert into SO3. Okay. And as it converts into SO3, delta H is negative here. It is a heterogeneous catalysis. SO3, when you react with H2O, converts into H2SO4. H2SO4 is fuming. Usually it will be fuming, so it is unstable form. So to keep it stable, what we do, we add excess amount of SO3, and that converts into H2S2O7, which is the oleum form. Okay. Here, so that is the one which stores in the acid. Okay. And H2S2O7 plus H2O will convert into 2 moles of H2SO4. Done.
Right.
Right. Next one is lead chamber process. S plus O2 converts into SO2. Okay. And SO2 plus O2 will convert into SO3 in the presence of NO2. And that is homogeneous catalysis. Clear? And SO2 plus NO2, basically this is the mechanism. First SO2 plus NO2 will convert into SO3 and NO. And NO plus O2 will again convert back into NO2. So this will make it a little faster reaction.
Right.
And once you make it SO3, it will convert into oleum. And that's how oleum is the way to store the H2SO4.
Okay.
H2SO4 is colorless, odorless, oily liquid, and it is viscous. Boiling point is very high for this one. It will show hydrogen bonding.
Sulfuric acid is oily.
Yes, beta, because of very strong hydrogen bonding.
Oh, that's new. I did not know that.
Pure form. Okay. Obviously, we cannot hold on to that. Okay. Next, if you have H2SO4, right, it will convert into H plus and HSO4 minus. That is the Ka value. Usually H2SO4 in
Sir?
aqueous solution is very
Hello,
large.
sir.
One second. So my mom wants to speak to you. So
Yes, ma'am.
Hello, sir. How are you?
One
Follow
second, ma'am. Okay. So sulfuric acid will show dissociation this way when it gives away first H plus, the Ka
Hmm.
value is very large. It is the second H plus which will make it slightly weaker. Of course, it's not very weak acid either, but yes, this is what you will see. Okay, but
Right.
this is again with some concentrated H2SO4. But if it is dilute, both this H plus and this H plus would be in a sufficient amount. So we almost write as if it is H2SO4 with a dilute aqueous form will be almost giving away 100% to H plus and SO4 2 minus. This is
Hmm.
what we write. Okay. Next, check out the reactions here. Just a minute. So H2SO4 acts like a dehydrating agent. So HCOH, when you react with concentrated H2SO4, it can remove water and the remaining part is carbon monoxide.
Hmm.
Same goes with oxalic acid. It can become CO and CO2. Glucose will completely convert into, carbon. Okay.
Hmm.
And when, if it is action with salts, you can see NaCl plus concentrated H2SO4 will give us HCl vapors and Na2SO4. Okay. While with CaF2 and concentrated H2SO4, it will convert into HF and calcium sulfate. Now, in these two cases, there is no oxidation or reduction happening. But
Hmm.
the minute you react with NaBr or NaI with concentrated H2SO4, now it will act like an oxidizing agent, which suggests the fact that fluorides and chlorides, right? I mean,
Hmm.
chlorine and fluorine are much stronger oxidizing agents than concentrated H2SO4. In fact,
Right.
if you write the oxidizing, okay, oxidation order, correct?
Hmm.
So obviously, fluorine will be the strongest. Then comes ozone, clear? Then comes
Hmm.
Cl2, sorry. Then comes KMNO4, okay? And then comes Cl2, and then comes K2Cr2O7, clear? In fact, before this,
Hmm.
there is one more peroxide also. But peroxide we don't use much in these cases, but yes, peroxide is more. Okay, K2Cr2O7. And then comes concentrated H2SO4. Got it?
Hmm.
And after that, you get bromine, then concentrated HNO3, and then
Hmm.
comes I2. Okay, so you got an idea. Like from fluorine to iodine, this is the sequence of compounds which will have certain oxidizing abilities. Okay,
Right.
next. This is all based on the E0 values, okay? Reduction potential
Hmm.
values. Next, if there is carbon converting it, reacting with concentrated H2SO4, it will completely oxidize into CO2. Sulfur completely oxidize into SO2. Okay.
Hmm.
Next one, if you notice metals, okay. So
Hmm.
zinc, when you react with dilute H2SO4, it can convert into ZnSO4 plus H2. Okay. And if you react with concentrated H2SO4, now what happens in the case of dilute? Because H2SO4 does not have that strength to oxidize, zinc will
Hmm.
still get oxidized, but it is the hydrogen which will get reduced. And that is a part of our reduction potential series.
Hmm.
But when you treat with concentrated H2SO4, now it is the sulfur which is acting like an oxidizing agent. So that will get reduced. And H2
Hmm.
formation is hardly observed. So everything will convert into SO2 and zinc will get oxidized to Zn plus 2 as usual.
Right.
And in electro potential series, reduction potential series, you will notice that hydrogen is here, correct? And then copper is above that, which means copper's reduction potential is positive, correct? So
Hmm.
therefore, if the copper 2 plus to copper is spontaneous and copper to copper 2 plus is non-spontaneous, then this reaction does not take place.
Hmm.
Okay. And the same logic applies to silver and mercury. While anything metal which has reduction potential lower than hydrogen, that include
Hmm.
tin, lead, iron, cadmium, nickel, cobalt, they all will get oxidized as usual to give H2. Okay.
Hmm.
And if copper reacts with concentrated H2SO4, that would have a similar effect as this one. That is copper sulfate plus SO2 plus H2. Okay.
Hmm.
Right. Now, this time it is not a redox reaction. But the change in the compound nature, see, if I take potassium ferrocyanide, react with a dilute H2SO4, so it will break the complexity of the molecule, convert into K2SO4, iron will convert into FeSO4, cyanide will take H plus from the solution, converts into HCl. This comes with the fact that cyanides are strongly basic, has strongly basic character. They can extract proton even from the complex positions and convert into HCl. But when you take concentrated H2SO4, it is not the oxidation that is happening, but it is the breaking of bonds, so that again it will convert into some new compounds. So K2SO4 FeSO4 is the same. Instead of cyanide taking H plus from here, the hydrolysis will be so violent that it will convert into carbon monoxide, and this nitrogen gets feed of hydrogen and converts into ammonium sulfate. Okay.
Gets what of hydrogen?
H plus. The lone pair from here you will have like this, isn't it? Minus.
Yeah.
So imagine like this. First, this minus, whatever it is there, it is directly connecting onto oxygen. Okay.
Oh, okay.
Clear? Well, I can't give you the exact mechanism, honestly. Okay. But you
Right.
can think this way. C triple bond N lone pair is been extracting on the H plus. Okay. And this will leave behind N double bond H form, correct?
Yes, sir.
Right. When this happens, the oxygen from the sulfur will attack beta, because this will start getting positive charge, isn't it?
Yes, sir.
And that's how from one end nitrogen keeps extracting proton, and from the other end oxygens keep attacking them.
Yes, sir.
That's how it will convert into a triple bond.
Okay, and then it became carbon monoxide.
Yeah. Done. Now the last thing is about thiosulfuric acid, or also known as the hypo. Okay.
Yes, sir.
Na2S2O3.5H2O. See,
Yes, sir.
it is a disproportionation reaction wherein sulfur, when you react with concentrated NaOH, will convert into Na2S2O3 and Na2S. Okay.
Right.
So the sulfur will convert into S2 minus, and some part of the sulfur will convert into thiosulfate. Okay. When you take excess of sulfur, the same Na2S, instead of having one sulfur, it can have a chain of it.
Right.
Because catenation property is good, so sulfur can actually exhibit up to 5, some 7, 9 like that. It can keep on going. Okay. So Na2S5 is more observed when you take excess of sulfur. Okay.
Right.
Na2S3 with hydrolysis, Na2S5 with hydrolysis, all of them, sorry, with oxidation, they all will convert into Na2S2O3. Okay.
Right.
Now, heating sulfur with Na2S2O3 is another method. You know, this is very standard method that is being used. Right. So I didn't mark this. Sorry. Sulfur plus Na2S2O3 will convert into Na2S2O3. And Na2S plus Na2SO3 plus iodine will also convert into Na2S2O3 plus NaI. Okay. And basically I minus iodine is getting reduced here. In fact, if you add further amount of iodine here, correct? If you add further more iodine to this one, it will convert into Na2S4O6 plus 2NaI. What do we call it? Iodometric titrations. Got it? Next, Na2S plus SO2 will also convert into Na2S2O3 plus sulfur. Here this is reducing agent, this is oxidizing agent. Okay. These are all the preparation reactions for thiosulfate. It is efflorescent with white color solid. Okay, that means it will be losing out water very easily in air. It will disproportionate on heating. It will convert into Na2SO4 plus Na2S5. Chemical reaction wise, when you add it with HCl, will simply get NaCl and H2SO3. And H2S2O3, which is thiosulfuric acid, on further heating will convert into sulfur and SO2. With iodine, it will become this one, which is iodometric titration. Now notice, When you directly react with chlorine, Cl2, okay, with moisture,
Right.
then it will convert into NaHSO4. Basically, now chlorine is oxidizing it so much that all the sulfur will convert into bisulfate.
Bruh.
And gives
Okay.
HCl. So this is called as anti-chlor. That means it is the thiosulfate is used as a reagent to remove any chlorine adsorption or any chlorine which is stuck in any reactions. Got it?
So
That's why it
then
is called
why is it
anti-chlor.
also called anti-IO?
Okay, this is not a gas now, usually. Chlorine is a gas. Okay, it's difficult to extract.
Fine.
Right. Na2S2O3 plus KMNO4. KMNO4 is a strong oxidizing agent. In neutral medium, it will convert into MnO2 and SO4 2 minus. And with AgBr, you know that in fact S2O3 2 minus can make a very strong complex. Okay, so even with AgI also it can make a complex. So AgBr will convert into this soluble complex. This we use as a conformation for silver ion. AgNO3 plus Na2S2O3 can directly form into this complex. And if you add excess of Ag, you'll get AgS2O3, which is white color complex. And if you add excess of S2O3, it will again convert back into the same complex. While this white complex, on heating it, we will get a black color PPT, which is Ag2S. Okay. This sequence for advanced, I think you should practice once. Correct?
Right.
Similarly, the next sequence also. S2O3 2 minus plus copper 2 plus. Just like iodine, how it acts like an oxidizing agent, here copper 2 plus will act like an oxidizing agent to oxidize this to tetrathionate. And copper will convert into a white PPT, Cu2S2O3. With excess amount, it will also become a complex. Okay. And on heating, this will also become black PPT. Got it? Right. With iron, it will become a violet color complex here. And with excess amount of Fe plus 3, the Fe plus 2, Fe plus 3 will convert, oxidize into Fe plus 3. This is a similar reaction of what we learn it as iodoform reaction. Got it? Clear beta? So that will finally convert into S4O6 2 minus, and iron will convert into Fe plus 3. Okay?
Right.
Next. S2O3 2 minus with CaCl2 will not make any reaction. And S2O3 2 minus with BaCl2 will make a white PPT first, BaS2O3. And that white PPT does not form any complex as such. Okay. So that is the overall reaction which will take place. Done, beta. Now, this is something which you're supposed to study in hydrogen. Okay. But I'm not sure, because hydrogen is not a specific topic for mains, correct? It could be asked as a part of group 16, although group 16 also is not a part of mains. Okay. But for advanced, it is definitely there. So we will revise it, here itself. Got it? What does hydrogen peroxide do? What is its reaction? Now notice. H2O2, by preparation, it is like this. Barium peroxide, when you add it to cold H2SO4, barium will get easily precipitated, and the leftover compound is peroxide. We can't take it warm or concentrated because the peroxide forming will immediately decompose into H2O and O2. Okay.
Right.
So the preferred form of barium peroxide is BaO2.8H2O. Okay. And next thing, you can see H3PO4 is more, preferred than H2SO4 in generally. Reason being, it will avoid any oxidation. Okay. So H3PO4 is not an oxidizing agent. So it will form barium phosphate, H2O and H2O2.
Right.
And barium oxide, when you react with carbon dioxide and peroxide here. Barium peroxide, when you react with carbon dioxide and H2O, that will also convert into barium carbonate and peroxide. Okay. Another way we can do is by hydrolysis of concentrated H2SO4. Concentrated H2SO4, when you notice, H2SO4 will dissociate as H plus and HSO4 minus, and 2 moles of H plus will convert into H2, that is the cathode reaction. At anode, HSO4 minus will become H2S2O8, which is Marshall's acid, right? So it will convert this into Marshall's acid plus 2 electrons. Marshall's
Right.
acid on hydrolysis first converts into peroxysulfuric acid plus H2SO4. Got it? H2SO5 plus H2SO4. And H2SO5, which is there, when you react with peroxide again, clear? Sorry, when you react with water again.
So give me
Yeah,
1 minute.
one
There's a
second.
problem.
Next, see. When it comes to cathode, you will have this H2O2 formation. Okay. Next, check out 2-ethyl anthraquinol. This is 2-ethyl anthraquinol, where you have OH and OH group on that. When you react with O2, what happens here? Radicals will form. Dot and dot will form here. This H dot and this H dot will actually combine with oxygen from both ends, convert that into peroxide. So in a way, if this is the oxygen we are talking about, this is where it appears. And this oxygen will convert into double bond and double bond, making into this compound. Quinone form. Okay, anthraquinone form. Anthraquinol will convert into anthraquinone. Okay.
Right.
Similarly, if you take potassium, peroxysulfate, disulfate, even that on adding with D2O or H2O, that will convert into D2O2 or H2O2. Okay.
Right.
Now, peroxide is usually colorless liquid. It crystallizes to form H2O2.H2O. It is a weak basic acid. It possesses hydrogen bonding and acts like both oxidizing and reducing agent. Okay. When it acts like an oxidizing agent, in fact, in acidic medium, its strength is much more as an oxidizing agent. What are the reactions it can make? Check. PBS, H2S, I minus, NO2 minus, SO32 minus, SO32 minus, iron with +2 oxidation state, NH2OH. All of them are respectively getting oxidized, while the other product is H2O. That means the reduced part is H2O. Okay.
Right.
So that, if you remember, I just wrote the list also, right? That's why I told you peroxide in acidic medium has a very strong acidic oxidizing nature. Okay. In fact, if you have Cr plus 3 also, it can oxidize into CrO4 2 minus in basic medium. If you have it in a basic medium. Got it? And next, Mn plus 2, H2O2 plus OH minus will give MnO2. Okay. So it is oxidizing Mn plus 2 also. Have you noticed in alkaline medium, its oxidizing nature is very less. Okay. So it is mostly the acidic medium that you need to look into. Next, H2O2 as a reducing agent. Okay. So again, we will see reducing agent in acidic medium as well as basic medium. So in acidic medium, it can act like a reducing agent. In basic medium also, it can act like a reducing agent. But it requires a stronger oxidizing agents. Like in acidic medium, KMnO4, HOCl and MnO2. These three can dominate. Of course, F2 and Cl2 will anyway be stronger. Got it? But apart of that, these three, if you notice, KMnO4 can convert into Mn plus 2. MnO2 can also convert into Mn plus 2, and HOCl will also act like a good oxidizing agent, converts into HCl. Okay. While alkaline medium, if you notice, H2O2 can oxidize ClO2, Cl2 to convert into, get reduced to form Cl minus. It can reduce KiO4 to Ki3. It can reduce Ag2O to get reduced here, Fe plus 3 to Fe plus 2. And this is potassium ferricyanide converting into ferrocyanide. Okay. Now, if you have noticed, there are three reactions which are happening slightly different. Check it out. One, have you noticed this one? here Fe plus 2 is converting into Fe plus 3, correct? When the minute you
Fe
put it
plus
in
2,
acidic
Fe
medium,
plus 3.
correct?
Yeah. Hmm.
But if I put that in basic
Basic
medium, what would
medium.
happen? Fe
Ulta.
plus 3 will get converted into Fe plus 2, okay?
Right.
So remember the difference in the medium, okay? Where it acts what?
Right.
Next, if Mn plus 2 is there, Mn plus 2 is converting into MnO2.
Right.
So here, again, I'm using peroxide in basic medium. And if I go to this side, that means I'm using acidic medium. I minus is converting into I2 in acidic medium, and I2 is converting into I minus in basic medium.
Right.
So these three reactions you need to remember because they are distinct. Okay?
Capiche.
Test wise, if you notice, Cr2O7 2 minus, it can be treated with peroxide to convert into CrO5, which is blue color solution. And it can be only stabilized if ether is been added. Otherwise, again, it will convert back into Cr plus 3. Okay.
Yes.
Next, peroxide, when you react with PBS, which is black color, now it will convert into a white color precipitate, which is PbSO4.
PbSO4.
And titanium Ti plus 4, when you react with H2O2, it will get a peroxy linkage to titanium here.
Right.
And that will be an orange color. Okay.
Right.
Now, H2O2 can be easily catalyzed, right, in the presence of dust. That means it can decompose very easily in the presence of dust, alkalis, glass, metal ions, MnO.
Right.
These are all the decomposing agents or catalysts. While H2O2 will
Right.
still be very stable when it is in urea, glycerol, phosphoric acid, Na2SNO3. These are all when you stored in a plastic bottles. Correct? So these are
Right.
called inhibitors. That means it will try to keep the peroxide more stable as as much stable as possible. Clear, beta?
Right.
I think this part, I hope you understood that. Yeah.
Right.
Right. Okay.